We're starting a two-part series on solving systems of linear equations in two variables. This is part 1. In part 1, we'll understand a system of linear equations, we'll solve a system of linear equations by graphing, and we'll also learn to solve a system by using the substitution method. So typically when we're given a system of linear equations, what we're going to be working with are two lines. So given two lines, the goal when solving the system is to determine the coordinates, the xy coordinates of where the two lines intersect. There's three possible outcomes which I'm going to demonstrate visually. So if we have two lines, they could intersect at one point, so there would be one xy pair or one solution. We also have lines that never intersect, parallel lines. So if we have this case, there would be no solution. Okay, and then we could also have lines that are identical, so the same line where it's one on top of the other, which would be infinitely many solutions, because all along that line, as it extends forever and ever, all of those xy pairs would satisfy both of the equations in the system. So on the next slide, I'm going to go over some definitions, and then we're going to put this visual with how many solutions there can be, along with the definitions together in a table. Okay, so some definitions. So there's two ways to describe the solution to a system of linear equation. The first is consistent, meaning there is at least one solution. So it could be one solution or infinitely many, and the system would be described as consistent. If there's no solution, then the system is described as inconsistent. Okay, and then there's also two ways to describe the lines that were given in the system. The lines could be independent, which means that they are two different lines, or the lines could be dependent, meaning that the lines are identical. Okay, so let's put this all together with how many solutions there are, the meaning of each, and the statement that would describe it. So if there's one solution, that means that the lines intersect at one point. Our statement is it's a consistent system because there's one solution, and since the lines are different, we describe that as independent. If there's no solution, it means the lines do not intersect, so the lines are parallel. It's described as inconsistent because there's no solution, but it's still independent because the lines are different. If there are infinitely many solutions, it means the lines are identical. This is described as consistent because there is at least one solution. In fact, there are infinitely many, but it's described as dependent because the lines are the same line, or they're identical. Okay. So let's solve the system by graphing. So first, I would advise to make sure that each line is in slope-intercept form so that we can graph the line using the slope and the y-intercept. We'll graph each line and then we'll determine where they intersect or the solution from the graph. So example 1, solve the system of equations by graphing. So we have x minus y equals 5 and x plus y equals negative 7. So on this first slide, I'm going to just get them into slope-intercept form, and then on the next slide, we will graph them. Okay, remember that slope-intercept form is y equals mx plus b. Okay, so for this first line, I'm going to write it down below. We want it solved for y, so I'm going to move x to the other side. So I have negative y is equal to negative x plus 5, and then we'll divide by negative 1 to get y is equal to x minus 5. So this is the first line. Okay, for the second line, we have x plus y is equal to negative 7. So to solve for x, we move, or to solve for y, we move x to the other side to get y is equal to negative x minus 7. Okay, so these are the two lines that we're working with that are in slope-intercept form. Okay, so I'm going to go to the next slide. We found that this line was y is equal to x minus 5, and this line was y equals negative x minus 7. Okay, so what we do is we graph each of them using the slope and the y-intercept. So for the first line, the y-intercept is negative 5, and the slope is just 1, so we go up 1, over 1, up 1, over 1. Okay, and we'll keep going. Okay, and for the second line, we'll start at negative 7, and then the slope is negative 1, so that's fall 1, crawl 1, or down 1, over 1. Okay, so we go down 1, over 1, down 1, over 1. Okay, and these lines intersect right here. So the solution of the system is the coordinates of this ordered pair. The x value is -1 because we move 1 to the left of the origin, and the y coordinate is -7. So the solution is -6. Yeah, -6. -1, -6 is our solution to this system. Okay, and the solution is written as an ordered pair because we are talking about a point on the coordinate plane where these two lines intersect. Okay. Next, solve the system of equations by graphing. So our lines are already in slope-intercept form, so we can start off by graphing them. Okay. So for the first line, the y-intercept is 1 and the slope is -2 or -2/1. So we go down 2/1, down 2/1. Okay, and then we have the second line is the y-intercept is -5 and the slope is also -2. So you might know what's going to happen. 1, 2, 3, 4, 5. And then we go down 2/1. Okay, these lines have the same slope, which means they're parallel, so they're not going to cross. Okay, so this is a case of no solution. Okay. Example 3, solve the system of equations by graphing. So again, on this first slide, I'm going to get them into slope-intercept form, and then we'll graph it on the next slide. Okay, so working with the first equation, -3x is equal to 1 minus y. I am actually going to move the 1 over from the right-hand side to the left so that I get y by itself right away. Okay, is equal to, I don't know why I wrote -3. Okay, and then we divide everything by -1 to get y is equal to 3x plus 1. Okay, and we'll do the same for the second equation. And so to get y by itself, we divide every single term by 2, and y is equal to 3x plus 1. As you can see, it's already the same equation. Okay, so this is y is equal to 3x plus 1. Did I write 2 on the last slide? No, 3x plus 1. Y equals 3x plus 1. Okay, so my slope my y-intercept for this first line is 1, and my slope is 3, or 3/1. So we go up 3/1. There's my first line. And my second line is also, my y-intercept is 1, and then we go up 3/1. Okay, so this, as you can see, is the same line. So there are infinitely many solutions. Okay. So next we're going to learn to solve a system in two variables by substitution. So the way that this works is one of the equations is solved for a variable or can easily be manipulated that way. So what that really means is that a variable is alone on one side of the equation. So that could look like x equals or y equals, okay? And then what we do is we substitute that equation into the second equation, which allows us to solve for a variable. Once we get the value of one variable, we can plug it into either of our equations to find the other. And we'll see how this works in our examples. Okay, so example 1, solving a system of linear equations using substitution. So we have x equals 3y minus 11 and 5x plus 4y equals -17. So notice that top equation, the variable is alone on one side. Okay, so we have x equals 3y minus 11. So we're going to substitute, we have an x in the second equation, and we're going to plug in the 3y minus 11 in for x. So we're substituting that in for x. And the reason it's substituted in for x is on a side by itself. X is equal to 3y minus 11. So instead of having x in the second equation, we're going to replace it with 3y minus 11. So we have 5 times 3y minus 11 plus 4y equals -17. Okay, and so now we solve this just like we would any other linear equation. So we distribute the 5 to get 15y minus 55 plus 4y equals -17. Okay, I'm going to combine like terms. Remember, when you're combining like terms on the same side, we are adding them up. Okay, and then I'm going to add 55 to both sides. And this gives us 19y is equal to 39. Okay, and now here we can solve for y by dividing both sides by 19 to get y is equal to 2. Okay, so that's the first part. Remember that since we're finding an ordered pair, for the system, we need an x coordinate and a y coordinate. So far, we've only found the y value. So what we do then is we plug in y equals 2 into either equation, choose which one you'd rather work with to get the x value. I'd rather work with the top one because it'll give me x right away. So see, I've plugged 2 in for y, minus 11. So this would be negative 5. Okay, so I get x equals negative 5. So on the next slide, we'll write the solution and then we'll describe the system. Okay, so the solution then, we found that there's one solution. It's written as an xy pair. So our solution then would be negative 5, comma 2. Okay. Our system then is consistent because there's a solution. And since these lines are different, it's not the same line, this would be described as independent. Let's do one more example of solving a system using substitution. So in this case, both of our equations are solved for a variable. So we have y equals 9x plus 13 and y equals 2x plus 48. So notice we have y equals y. So y equals 9x plus 13 can go into the y in the second equation. Okay, so in one sense, we're just setting these equal to each other because they're both equal to y. Okay. So we have 9x plus 13 is equal to 2x plus 48. And again, we're able to solve for x because that's the only variable in this equation. So I'm going to subtract 2x from both sides, and I'm going to subtract 13 from both sides to get 7x is equal to 35. We'll divide both sides by 7 to get x equals 5. Okay, now to get the y value, you can use either the top or the bottom original equation, y equals 9x plus 13, or y equals 2x plus 48. I'll probably use the second just because, I don't know, multiplying by 2 is a little bit smaller than multiplying by 9, but you could use either one. So we have y equals 2 times our x value. Remember, this was x, plus 48. So y is equal to 10 plus 48, so y is equal to 58. Okay, so we'll go to the next slide to describe the solution. So there's one solution. As an xy pair, it's 5, 58. Since there is a solution, the system is consistent. Since these are different lines, the lines are independent. Thank you for watching. We'll continue learning about how to solve systems and check solutions in the next lesson.